Here we go. A number one. A skydiver in the spread eagle position opens the parachute. Is the diver accelerated? The answer is?
Yeah.
Got about a 50-50 there. The answer is yes. Yes, there is acceleration. And the reasoning is there a change in velocity? If there's a change in velocity, then there is an acceleration. Okay? So if the velocity is down, then the acceleration is up. And there's your answer to B, right? So an acceleration up changes the velocity. So there's an acceleration. That's because the cameraman keeps going, right? Yeah, no, the skydiver does not bounce up into the air. Okay, number two, a weightlifter lifts a 115 kilogram barbell from the ground. How does the force exerted by the lifter compare with the weight of the barbell? Well, this probably shouldn't be a multiple choice, although I'm trying to just to help you out to think about what possible answers are. But the real answer is at the start, it's just like pedaling that bike, right? At the start, when you're lifting it, you've got your weight force down. You're going to need a greater applied force to accelerate it. But once you get it moving, they are equal. So you'll equal. Once you get it moving, you just got to get it moving, and then equal. It's more at the start to get it going, and then it's equal. Objects in motion stay in motion, so you only need enough force to balance the weight force. Now, how does the force exerted by a lifter on the barbell compare with the force exerted by the barbell on the lifter? Those are equal. That is action-reaction. Equal. Equal. Remind me, we need laptops too. Number three. Now, this is a great question. Suppose you put a wooden block against the wall and push it horizontally to keep it from falling. Draw a diagram showing the force on the block and the cause of those forces. Pay special attention to the normal force and the weight of the block. Are they in the same direction? Well, you should have at least been able to come up with the weight force, which is down, right? Weight force is always down, gravity. And because the hand that's not attached to any body is pushing, that means that the applied force is this way, isn't it? Right? The applied force is that way. Okay, now what else is there? Well, there is a normal force, and normal forces are always, they're not always up, they are always perpendicular to the surface. And so your normal force is this way. Normal force is perpendicular to the surface. Okay? So the normal force and the applied force are actually balanced. Now, what's holding the block in the air? Friction. Because if there was no friction, what would it do? Slide down, exactly, right? So when I hold the calculator up against there, all right? What's holding it in place? Friction. No, I'm applying the force. Friction's what's holding it up, right? And if I don't push as hard, it falls. You should try that with someone's phone, maybe.
Doctor, I'm like your case.
There you go. Okay, number four. Explain why an aluminum ball and a steel ball of similar size and shape drop from the same height reach the same ground at the same time. Well, they will, provided that the height is small enough. We actually need some in this class, Nicole. We're going to put that down. We're going to make it. I know, sad face. Right? So if they're at a reasonably low height and air resistance is negligible, they would land at the same time. But if you were to take them, say, to the top of the Empire State Building, well, which one would land first? The steel one, right? Because the lighter one, the aluminum one, would reach terminal velocity faster and it would not accelerate as much. So the steel one would actually land faster if air resistance is significant, which happens when you're at a higher building. Can you tell me some examples of following objects for which air resistance cannot be ignored? What are things that you must include air resistance for? Skydivers, parachutes, pieces of paper, basically anything that is somewhat light. and not aerodynamic. Right? Number 6, give examples of following objects which aerodynamics can be ignored. Things that are aerodynamic. Arrows, bullets.
Spaceship.
Well, I suppose, in space.
Yeah.
Right? Yeah. Basically things that are aerodynamic. And you know what? I decided this morning I'm leaving out number 7 for another day. Yeah, number 7 I think I'm going to leave for another day. Maybe I'll write it out. I need to write it out. This is where I was going to work out. I will write out number 7. Okay, so here's what I want you to do.